Good evening, all. Am I audible, guys?
Yes, Ram.
Thank you. Okay. Today we are going to discuss the another important service. I mean, LVM is the concept. LVM. So in the Linux environment, LVM concept is very, very, very important. So everyone will face LVM interview questions as a system admin or Linux admin. Okay. So what is the use of LVM and how to implement LVM in Linux admin level? So today I will show you. So first one is LVM full form is Logical Volume Manager. Logical Volume Manager. LVM is a form of Advanced Partition Management. Advanced Partition Management. So remember, I told you two partition managements already. The first one is standard partition and the second one is RAID partition mount points. So in the standard partition means it is like a static partition. So with standard partition, we cannot resize the what file system sizes. I mean, if you create any partition with 3 GB or 2 GB or any with size, so we cannot expand in future, maybe 2 to 3, 3 to 4 like that. So that is the first drawback in the standard partition. And even standard partitions are not offering any kind of redundancy. I mean, it is called what security. So that's why in the last class, we have successfully implemented redundant array of inexpensive disks. I mean, how to provide the what backups for the data. So which is called RAID concept. So today, the LVM what says, again, it is also one more advanced partition management. So with help of LVM, easily we can resize the file system sizes. So LVM advantage is resizing file system sizes. That means partition sizes. So again, LVM will use, we can combine multiple hard drives as a single pool of disk space, single pool of disk space. So we can merge many hard drives and make it as a single hard drive. But LVM is a method of allocating hard drive space into logical volumes that can be easily resized of partitions with LVM. So this is the main advantage of LVM. What is the LVM benefit? So with help of LVM to resizing partition sizes, to resizing file system sizes. So those file systems, again, we can mount it and use it. But what are the advantages with LVM? Flexible capacity, resizable storage pools, online data relocation, convenient device naming, and LVM along with RAID also, disk striping, mirroring, snapshots. So everything is supported by LVM. That's why in the real environment, almost partitions are, mount points are running with LVM only. So in most cases, mount points are running with what? LVM partitions only. So what is the use of LVM? To resizing existing file system sizes. This is the main point. Now, so in the LVM, it's running three major components. One is physical volumes, second one is volume group, and third one is logical volumes. So once again, PVs, it's nothing but physical volumes. VGs, volume groups. LVs, logical volumes. So please be understand here. Physical volumes means your hard drives, like your partitions. So multiple physical volumes is nothing but volume group. So the same concept. In the last class, we have combined multiple drives as a one meta disk. Same way here, multiple physical volumes combined to one volume group. So for example, the physical volume size is 3 GB, then 3 GB, 3 GB, then volume group size is 9 GB. So this is the what pool of space. From this space, you will create multiple logical volumes, multiple logical volumes. So each volume created from the volume group, from the volume group. So that's why it is an it is a structure, physical volumes, volume group, logical volumes. So ultimately, we will offer partitions, I mean file systems, through logical volumes only. So logical volumes are created from the volume group. But what is the volume group? The collection of physical volumes is nothing but volume group. So remember these three components: physical volumes, volume group, logical volumes. Here is the what definition of each component. Physical volumes are underlying physical devices. I mean, these are the what partitions or hard disks. So to use the devices for an LVM logical volume, the device must be initialized as a physical volume. The meaning is the volume group consider only physical volumes. Physical volumes means so first devices are raw devices. Volume group doesn't consider directly raw devices. So first person what to do, engineer what to do, we need to convert physical devices to physical volumes. Then only volume group will consider physical volumes. So the second important thing, volume groups. Volume groups means the collection of physical volumes. That means a pool of disk space. If you combine three devices or two devices, even you will take a one big volume, big size device also. So no need to combine multiple devices. Just take the what even one device with terabytes of data. But you must to convert as a physical volumes. Then so the volume group disk space divided into units of fixed size called extents. So volume group internally divided into extents. An extent is the smallest unit of space that can be allocated to logical volumes. So at the time of practical success, I will tell you what is the extents. And the next one is logical volumes. So an LVM, a volume group is divided up into logical volumes. That's what I'm saying. Logical volumes are created from the volume group only. So these logical volumes we can use for the mount points. For the mount points. So the logical partitions which can resize, format, and mount it. So now how to implement this LVM with help of these three components practically I will show you now. So before going to practical lectures, so once again, what are the LVM configuration files? So by default, the LVM settings are under etc/LVM. LVM.conf is the main configuration file. I mean, all settings are under LVM.conf file. And cache location is /etc LVM cache. In case any automatic backups, then etc LVM backup is there. And archive files. So zip file location is here etc LVM archive. But remember, all files are auxiliary location in the /etc LVM. Up to LVM is the common. So you will go for etc LVM and find the what all files by default. Okay. Now I will show you how to implement LVM structure in the environment also follow the what same process. Okay. So again, we need multiple partitions. We need partitions, guys. So how to create a partitions? So again, don't confuse. We need to take hard drives, I mean hard disks, or directly you will take the word partitions also. Just assume each partition as a one physical drive. So in that case, we don't have multiple physical drives. That's why we will consider the word partitions. Partitions as a physical drives. Okay. Now, first one is, let me create some partitions. Slash dev, same process again. NVMe 0 and 1. If I enter, so already existing partitions are 11. So now let me create the what? Another one. N is the option to add a new partition. Then N is the option to add a new partition. So now 12th one, the first partition size, let me take, here it is called what? Again, 3 GB is my first partition size. I mean 12th one. So now I will take another partition. The next partition size, again it is called what? 3 GB. And again I will take the what? Another partition. The third one also with 3 GB. So we have successfully created three partition, three partitions, 12, 13, 14. So three created. So if I check P, so the number of partitions are 14 now. 12, 13, 14. So now, as usual, I want to change the partition IDs because I want to identify. So these three partitions related to LVM. So how to change the ID values? So how to change the ID values? Then T is the option to change the ID value. So first let me change the 12th one. It is called what? LVM. Then enter. So Linux file system, change it to LVM. Then the next one is to change 13th one. So it is called what? LVM. And next I will go for the what? 14th one, which is called what? LVM. So now I have successfully converted. So volume names, I mean it is called what? Partition types from Linux file system to Linux LVM. So how do you know that? Let me check again P. Okay. So now these three partitions related to LVM partitions. Okay. How to save it? W is the option to save changes. Perfect. So now partitions are successfully created. After creating partitions, you must to run part2probe slash dev nvme 0 n1 enter. So now partitions are successfully updated. Partitions are successfully updated. Now, once again, we will check it lsblk. So 12, 13, 14. So these three are the what? Now LVM related partition, but see, already mount points are 8, 9, 10, 11. These are the what? MD0 related partition. I mean, see this, these are all of the what? RAID 5 partitions in the last class. So after implementing LVM, even 12, 13, 14 also, it's looking like LVM partitions. Okay. So now your physical devices are ready. So in case if you have any physical devices, okay, I have SDA or the second device is SDB or my third device is, it is called what? Slash SDC. Instead of your device names, so we are considering partitions, guys. Okay. The first step is how to create physical volumes. So you must convert raw devices into physical volumes. So PV create is the command. Then what devices, I mean what partitions we need to convert. So I want to convert the partition names are which are like 12, 13 and 14. So now partition 12, partition 13, partition 14. If I enter, now physical volumes 12, 13, 14 successfully created. Okay, three partitions are successfully created. So how do you know that? If you run PVS, I mean PV scan command. What is the PV scan? It's combined the three devices sizes. Now if I enter, see that total devices are three devices sizes completely 9 GB. It is the first important command. And if you run PVS command, I mean each each physical volume details are 12, 13, 14. So 12th one size is 3, 3, 3. But right now it's running LVM version 2 format. That means the version 2 package is in the backend. And you want to get complete details about your details like LV display. LV display is the command. Then each physical volume details you will get it. Yeah, the command is PV display. So PVS is the short description. PVS is a short description. PV display is a full description. So now see this, all details about your three devices. So the first two device is here 12th device. I mean the 12th partition size is 3 GB and 13th partition size is 3 GB and 14th partition size also 3 GB. So you want to get each physical volume details like one by one also it is possible. I want to get 12th one only. So now the 12th one size. Okay, same like the partition UUIDs. Here is the what, this is not partition. These are the what physical volume UUIDs. Okay, right. So now how to combine multiple devices as a volume group. So just now I told you the second step as per architecture, the combination of physical volumes is nothing but volume group. So how to create a volume group? Okay, so volume group means the command is VG create, guys. The commands are very easy. PV create, VG create, LV create like. So VG create. So the volume group name. So which name you want to create it. So for example, I want to create my volume group name is India. My volume group is name is India. If I space, then which devices we need to combine. So I want to combine 12th one and 13th one. So right now I will use, we are using only two devices, partition 12 and partition 13. So but 14th one is separate device. Same like I will use the what in the next level. So right now we are using only two devices combined to the volume group name is India. If I enter, so now volume group India successfully created. So you want to get the details again. So VGS is the short form and VG display is the what full form. So full description. So in the VG display, volume group name is India. The format is LVM2. How many meta disks are added? Two only. Then volume group, the capacity is read write capacity and volume group even the status is resizable. I mean we can expand the what your volume group, reduce the what volume group sizes. Now here please understand the volume group size. So 3 GB, 3 GB. So overall how much? 6 GB. So the 6 GB means here total PS. I mean, remember I told you in the definition of the volume group. So volume group means fixed size called extends. I mean volume group is divided into small units called extends. Extends. That means that 6 GB is divided into 1534 cells, 1534 units. So one unit sizes, I mean one extend size is 4 MB. One extend size is 4 MB. That means PE size, physical extended size. That is called what? Extend. One extend size is by default 4 MB. The meaning is 1534 into 4. You can calculate it. It is equivalent to 6 GB. It is equivalent to what? 6 GB. I mean the sizes showing either PEs or sizes. So this is the what our human readable format. But LVM uses extension sizes. I mean extends only. So now how many extents are there? 1534 extents are there. That those extensions are each extension size is 4 MB. That is my point. I mean, hard volume group is divided into small cells internally, but one cell size is by default 4 MB. 4 MB into 1534. So by default, one extend size is 4 MB. In case sometimes people will take the word more block sizes. I mean, one extend size is more. Then how to take the word extend size? Then people will consider S is the option. For example, I want to take one extend size is 8 MB. So then this is called what? S is the option, which is 8 MB. But again, we cannot create the what? Physical extend size because already the volume group is created with 4 MB. So you want to change this value, then you can delete and recreate it. Otherwise, we can apply for the what? Another partitions. Again, we can create another volume group. So if I run it, see that a volume group called India already exists. So that's why here my concern is how to change the what extend value. So while creating only, we can change the what extend value. But once you create it with 4 MB or 8 MB, we cannot change later. Okay. While creating volume group, so just you will decide how much PE size you want. So if you don't specify the PE value, I mean the size of the PE, by default, LVM consider one block size is 4 MB. This is the what? Next important point. Then the third important thing, the pool of disk space is ready. I mean your volume group space is ready. Then how to create logical volumes from the volume group. So this is the word, the main step, creating logical volumes. So LV create is the command. LV create is the command. Hyphen L list. So I want to create one logical volume size is 2 GB. I want to create one logical volume size is 2 GB. Then space hyphen N is the option to create a new logical volume from the India volume group to it is called what? AP, Andhra Pradesh, for example. So now we are creating so one logical volume from the group of India. So if I enter, see this volume group AP not found. Then what is the problem? Here we need to consider the word slash IP. Now logical volume AP successfully created. So this AP is created in the volume group of India. Generally in the volume group India 6 GB is there. Now AP logical volume occupied 2 GB from the group of India. So now if you verify LV display, I mean the LV display, see that India AP occupied 2 GB. 2 GB is nothing but 512 PEs, 512 extends. Calculated 4 into 512, it is equivalent to so 2 GB. 4 into 512, it is equivalent to 2 GB. But if you verify the word volume group, so now how many PEs are allocated? 512 PEs are completed. That means 2 GB is already dedicated to one logical volume. So the pending PEs are pending size in the volume group 1022 PEs are equivalent to 4 GB pending in the volume group. Okay. So now we have successfully created one logical volume 2 GB. Then what to do? How to use this logical volume? As usual. So again, we can create a what? File system mkfs dot xfs hyphen f. Then what is my logical volume name? The full path is under India, which is called what? AP. Enter. So now file system successfully created. The file system name is xfs. Then I will go for the second step is the what? Mounting as usual. So for creating directory, mkdir. Okay, for example, I want to store LVM data here. Otherwise, you will keep the what Oracle data, cloud data, Azure data. Okay, my identification LVM data. So now the mount point is successfully created. Then what is the next important thing? Where to update the details? You know already how to mounting the file system, mount space, then device name is, it is called what? The volume group name is India, and then it is called what? AP. And then, sorry, AP. Then what is the mount point name? LVM data is mount point name. So now successfully mounted. Now you can check it here. See this. LVM data is a mount point. AWS data is a mount point. RHL9 data is a mount point, and multiple mount points are there. But remember, so here is the what? RHL9 data mounted to ISO image. Partition 5 is the standard partition. In the last class, important data, I mean, RAID data mount point has been deleted in the last class. But now LVM data mount point is there. So this mount point is offering over the what? LVM structure. Over the what? LVM structure. See that the ultimately agenda is what? To providing my mount points only. But you must to understand what are the benefits. So in the first class, I told you we are offering mount points from the standard partitions. But standard partition drawback is the what? This standard partition size is 3 GB. So now this mount point size, I mean this file system size, we cannot increase. We cannot increase. So even that standard partition doesn't offer any security features. That's why in the last class, for the security reason, we have implemented multiple devices as a single drive with RAID concept. But now today, for the another feature, so I want to implement the what? I mean resize the what file system sizes. Today I have created 2 GB only. But maybe after 3 days, maybe people will add the what data in the what LVM. So now definitely they will ask more GB size of the what this mount point. Then how to increase the file system size? So that's why LVM concept is very idea. So based on the requirement, people to increase the what this file system sizes. But you want to resize the file system size, the backend that mount point should be LVM format only. The device format is LVM only. LVM only supports resizing file system. RAID supports backup purpose. Standard partitions means there is no best features. Okay, right. So LVM data mount point is ready. If I go for permanent mounting, go to etc fstf file. In the fstf file, again I will go. What is my mount point name? The mount point name is India. It is called what? AP is the device name. Then the second important thing, it is a LVM data is the mount point. Then what file system is created within the drive? XFS, again, defaults, which is called what? 0, 0. As usual, same process. This is the what? RAID concept. This is the what? LVM mount point. This is the what? Loop mount point. I mean, IOC image mount point. And this is the what? Your standard mount point. All mount points are ready. But you can consider the what? Okay, everything is a mount point. We need to understand what are the benefits with the devices. Now, save and quit, and definitely run the command. After editing this file, systemctl daemon reload option. Once reloaded, then we will run the command mount space -a for all, or mount space. What is your mount point name? Just run the command LVM data, but already mounted. That's why device is already mounted is the message. And now we can check it again. So your mount point is ready. Your mount point is ready. LVM data mount point is ready. So now people to use this LVM data mount point. So one day people are asking, already my mount point size is completed. So please be increase the word that LVM data mount point size, LVM data file system size. You got a mail. I mean, this is the ticket. So now please be increase the word. My mount point size is 2 GB to 5 GB or 2 GB to 3 GB or something like. So admin what to do? So they will consider the word first. What contains LVM data? What people have been stored within the LVM data. So everything they are verified, data is important means, then they will expand the what file system sizes. Maybe data is not an important, then people will take the backup and again they will provide the what the same size only. Okay, so here how to consider? I mean, how to increase the file system size. That is the main benefit of the LVM. So we cannot increase the what file system's standard partition. We cannot increase the what RAID partition, but only we can increase the what LVM through partitions only, LVM through file systems only. So how to increase the file system sizes? Resizing file systems. So here we can use LV resize is the command. LV resize is the command. LV resize again hyphen L plus I want to increase another 2 GB for these guys. So what is the mount point name, which is called what? Like it is a LVM. Sorry. What is the device name? /dev India AP. So I want to increase the what? DEV India AP sizes. But even see the another advantage. I'll tell you. See that the logical volume India AP successfully resized from the 2 GB to here it is called what? 4 GB. 2 GB to what? 4 GB. I mean previously we have 512 extends. Now 1024 extends. Okay, so now if you check LV display again, LV display, so now the volume size is here 4 GB. How many PEs are there? 1024. If you go for VG display, so the occupied size is already it is called what? 1024 4 GB is occupied, remaining 510, I mean 2 GB is pending. Out of 6 GB, 4 GB is used. Pending size is only 2 GB. So this is the proper way people to increase the what file system sizes. But we can observe still if you run df space hyphen h command, so what is the size of the your LVM data? Still it's showing 2 GB only. It's running 2 GB only. But actually this mount point size is now 4 GB. It's not updated. Disk free size is not updated. So this is also one good interview question. So even after updating my LB resize command, still my mount point size is showing the old one. I mean 2 GB or 3 GB or something. But what command we need to apply for updating your mount point? So that is called what? XFS underscore growfs is the command. XFS underscore growfs. Then what is your device name? It is called what /dev like India and AP. If I enter, so successfully updated. Now check it df space hyphen h. What is the LVM data size now? It is called what? 4 GB. So this is the what? Final point. I mean, so now the sizes has been replaced. I mean, it is called what? Resized. Okay, size has been resized. Now you want to reduce the size. For example, the same process, instead of here plus, you will use the what minus. And instead of LV resize, then we can use LV reduce is the command. But remember everyone, in real environment, especially in the production environment, people never reduce the storage size. People never reduce the storage size because when you're trying to reduce storages, definitely you will lose the what your data. So once file system has been updated, don't trying to reduce the what sizes. Okay, remember this point. It is never, I mean, it's mandatory to reduce the file system means, then first take the what entire file system backup, then you will go for the what reduce option. But without backup, don't go for the what LV reduce command. Just for identification, LV reduce command is there to reducing the what sizes, but don't apply LV reduce. Every day we will use LV extend command only. LV resize or LV extend. Okay, this is the command to reducing the what file system. Okay, so and the next important thing, and the next one is what is the VG size, guys? So now VG display volume group size is 2 GB. But again, I want one more logical volume. But how many logical volumes are there? If you run LV display, so one logical volume is there. So let me create LV create. Okay, one more person is asking, I want one mount point through LVM. So now we are creating -L. So now we are trying to create 3 GB size. So what is the mount point name? So I want to create with -N. It is with write the full path name. Otherwise you can write India. I want to create like mount point name is for example TS. Okay, Telangana. Okay, so now I want to create the another mount point. Okay, so now if I trying to create another mount point, what happens? See, volume group India has insufficient free space because it's required 3 GB means 768 extensions are required. But in the volume group, now we have only, I think, in the VG display, how many extensions are there? 510 is there, but actually it is 510 equal to 2 GB. But here I'm asking, I mean, we are trying to create 3 GB, I mean 768 extensions are required. Then what to do? So that's what here, remember, again in the architecture, see this, when the volume group, I mean every partition logical volume occupied the size from the volume group only. In case there is no space in the volume group, then people to add the what? Physical volumes like. So just consider the what? Your house, guys. So for example, you will fill the what? Your water tank. Everyone will use the what? Water from the tank. In case there is no water in the tank, how people will use? Then people will fill the what? Again tank. So this is the what? Pool of water. Same like pool of disk space here as a volume group. So we need to add the what? Physical volumes inside the what? Volume group. So now in previously we have added two physical volumes. Now let me add the what? Third one, because the person is asking one more volume group, one more logical volume, but there is no space in the volume group. Then how to increase volume group size? Increasing volume group size means need to add the what? Physical volumes in the group. So now how to add the what? Physical volumes? Again, the command is VG extend. VG volume group extend means VG extend. Then volume group name is India. Then I want to add the volume group device name is partition 14. I mean 12, 13 previously we have added. Now 14th one is successfully extended. Now if you go for VG display, then here the free space is 4.9 GB is there. Previously 2 GB, now 3 GB is added. Overall it is called what? 5 GB is there. So now free space is available. Now we'll go for the what? Creating the 3 GB logical volume successfully created. This is the way. I mean, you want to managing logical volumes. Definitely the space is required within the what? Volume group. There is no space in the volume group and people to add the what? Devices into volume groups. That's what here is the what? 2 GB, 3 GB partitions. But in the real time, people will add the what? Terabytes of data in the volume group. Okay, from that volume group, multiple mount points they will create. I mean multiple logical volumes they will create and operate it. So if a person is asking mount point, then 100% they are created from the volume group only. In case already running volume, logical volume is there, they are asking extending size, then we can extend the what? Size of the logical volume. We can find out what logical volume is there. That logical volume is under which group? I mean, what is the group name? So first find out, then it can increase the what? Size of the logical volume. Because here only one volume group, one logical volume. But in the environment, multiple volume groups are there, multiple bound points are there. Okay, but that's why compared to standard partition, the another advantage is in that volume concept. Here, device namings are the standard partitions are must be NVMe 0, N1 partition by NVMe 0, N1 partition for like that. These are the what? Standard partition names. But in the LVM RAID partitions, advantage is the what? Device names are, naming conventions are easy. I mean, based on your project requirement, project names, customer names, people will create the what? Device names. Okay, for example, right now I supported to Access Bank customer. Then people are created, volume group name is Access Bank. Then they are created multiple mount points with the name Access Bank like that. So their device namings are convenient compared to standard partitions. So this is the advantage of LVM concept. LVM main agenda is the what? Resizing file system sizes. Standard partitions doesn't support resizing file systems. LVM only supports resizing file systems. So that's why you want to working on LVM, but already in the real time LVM is running. The new engineers every day we will increase the what sizes of the partitions, but they want to resize the partitions. Definitely knowledge on backend structure. Okay, LVM means physical volumes are there, volume groups are there, logical volumes are there. So now we are operating logical volumes. So logical volume sizes from the volume group, that means a pool of data, pool of space. So where is the pool of space? Okay, the volume group is created from the physical volumes. What physical volumes are there? If you run PV display, now three physical volumes are there: 12, 13, 14. If you run VG display, so multiple volume groups are there. So it will display the what volume groups. Maybe the big structure is there. You will run the what single command. So India only one. If you have second one, here list out the what all volume groups. So at that time, you want to display volume group only India, then it will display the what? India volume group. You are maybe the volume group name is world is there, or maybe volume group name is IBM is there. So like it will display the what? That particular volume group only. Okay. So how to reduce volume group names? I mean volume group sizes. Again, reducing volume groups. Reducing volume groups means to removing physical volumes from the group. Adding, I mean increasing volume group is nothing but what? It's adding the what? Physical volume. And removing volume group is nothing but what? Removing the what? Physical volume. I mean reducing the group means removing the physical volumes. How to remove? VG reduces the command. Again, so never reducing the what? Partition sizes, file system sizes. So just commands are there. So as a trainer, I need to explain the what all commands. But in the real time, every time we will use the what? Increasing sizes. I mean extending sizes only. Okay. I want to reduce under DEV like partition names NVMe 0, NVMe 0, N1 partition 14 from the volume group name of India. Then if I enter, see that physical volume India still in use. See that in case the partition 4 is available, then you can remove it. But we cannot remove. What is the reason? So the partition 4 sizes, I mean the combination 9 GB is there. So in the volume group VG display, there is no free space. Only 2 GB is the free. But generally this partition size is 3 GB. That's why it is in use. Then what to do? First we will consider the what? LV display. What are the logical volumes? Okay, TS is there. So now in case this logical volume is unused, then let me delete LV. Remove is the command. Then what is the volume logical volume name? It is called what? TS. So do you want to delete the what? TS? In case this TS is already mounted, you know that. Go to FSTF file first, remove the entry, then unmount the what file system, and then come to the what? India TS and delete the what? Logical volume. And now in the VG display, the free space is there. Now 4.99 GB is free. So now we will go for the what? Reducing logical volume. Now 14 is successfully removed because 3 GB space is free. So this partition recommends 3 GB. So 3 GB is completed. If you run VG display, see that remaining 1.18 GB and two devices are under the volume group. And finally, where is the configuration settings? Where is the configuration settings? I told you the auxiliary location is /etc LVM. I mean the main location for the LVM, this is archive location. I mean folder is for backups, backup directory, cache location. And what is our configuration file? The LVM, lvm.conf. Just open lvm.conf file is there. lvm.conf file is there. Within the lvm.conf, all things are available. So you want to change the backup locations, you want to change the what settings for the LVM and everything is ready. For example, let me find backup. So here is the what backup settings. Okay. What is the backup location? By default, backup directory location is /etc/LVM/backup. The meaning is maybe if you remove logical volume, so that logical volume or volume group backup is by default under etc lvm.backup. When it will take the word backup, so the backup you can uncomment it. So if you uncomment this, now this backup directory will be work. Okay. So in the backup directory, here is the what retention minutes. That means time. So how many days you want to keep this backup? Okay, I want to keep retention period is 30 days. I mean backup is available 30 days. After 30 days, the backups will be deleted automatically. So you want to change any LVM settings, we can use the word configuration file. Okay, and you want to enable the word archive files. So now archive directory is /etc lvm.archive file. So now let me save it. Let me save. Then check it in the location. I'm in backup directory. Only volume group name is India is ready. Okay. So now ls in the archive, see that logical volumes are here. Under India volume group, see volume group IDs. I mean here it is called what ID values for the backup. It is called what archive zip files. But where is the volume group backup? Under ls backup, India is there. Okay. So this is the what backup location for the volume groups and logical volumes. Now, finally, please understand you want to change LVM settings. LVM.conf is the main file. And now, how to clean your complete LVM structure. So first remember, once again, same format and don't delete first physical volumes and don't delete the what volume groups. What is the structure first? Bottom to top. First, you can unmount the what in used file system. So is there any mount points related to LVM? Yes, it's a mounted. So we cannot delete volume groups, logical volumes and everything. Then what to do? First, you can unmount your file system data. I mean LVM data unmounted. Then next important thing, you must to remove entries inside the what fstab file. So I have deleted and RAID partition also deleted and ISO partition also deleted because no need those things. Otherwise, I will keep the what undo option. Or you want to use the same one points in next time, and people will consider the word hash is your what single line comment. In case you don't want it, simply we can delete a line, then save and quit. This is the first important thing. So then we will confirm again is mounted or unmounted. So there is no LVM data mount point. Then once unmounted, you will remove the what? LV remove. The logical volume name is /div India AP. So now logical volume successfully removed. So then you can check it. LV display, there is no logical volume. That's why in the VG display volume group, totally 534 PEs are free out of, I mean, 6 GB is completely free because there is no logical volumes. This is the first one. So now I want to remove volume group. So directly we can remove the what volume group? VG remove. The volume group name is India directly. So now volume group India successfully removed. Then VG display is the option. No volume group. And finally, physical volumes are there. Then PV display. So 3 physical volumes are there. Then how to delete the physical volumes? Everyone PV remove. Then /dev. Those are like partition 12, 13 and 14. I want to remove all. All are removed. Then we can check it. PV display, no physical volumes. So everything is cleaned up. But sometimes in the environment, what happened? any partition or any device is failure, then how people will moving the data from one to another. So generally, for example, pb move is the command. Okay, for example, in the slash dev nvme0 nvme0 n1 partition 12 has been failed. I mean something went wrong in the device of partition 12. Then before removing before removing the device, people what to do? So they will moving the data in the slash dev nvme0, I mean NVMe0 N1 partition new one. I mean, you will create what another new partition, then moving the data from partition 12 to partition 15 like this. So they are moving the data, physical data. I mean, moving the what? One device to another device. They will like it. After moving, again, PV extend. I mean, this device is added into that particular volume group. VG extend volume group namespace, this device. Then this device will be added with old data like that. Okay, so this is called what exactly? LVM concept in the real time. But every time you will face two main questions. What is the command to increasing logical volume size, or what is the command to update your disk free size? And what may I know what exactly concept of the LVM? I mean, can you explain step by step how to implement LVM? Okay, majorly these three or four commands, and you want to change PE size. What is meant by PE size, and how to change the PE size? Okay, so mostly these are the what regular commands in the LVM structure. Okay, once again, the commands are very easy. First, for creating PVs, PV create. After PV create option, to scan the PVs, I mean to combination PV scan. You want to verify the displays, PV display is the command. PV display is the command, or short form is PVS. So these are the what? Physical volumes. And then volume groups means instead of PV, you will keep the what? Volume group. VG create. Then VG display. And then VG extend is the what? Another option, or VG reduce is the command. Then logical volumes level, LV create is the command. Then LV display is the command, or it is called what? LVS for the short form. Then what is the command? LV reduce is the command, or LV extend is the command. LV resize or LV extend is the command. Okay, so now for only one command for updating file system, xfs underscore grow fs is the command. So these are the commands in the LVM structure. If you know this command, then operating LVM is very easy. But in the real environment, multiple mount points are there. Almost every mount point running with LVM structure only. As a new engineer in the company, you will extend the what every time logical volume sizes. But how to extend the logical volume sizes? And before extending, you must to know the what are the backend architecture of the LVM. If you know the backend architecture, easily to work on the what LVM structure. So this is the concept of LVM in the environment. So if you have any queries, now please ask.